the physical science lesson video for chapter 6, section 1. And as always, if you'd like my videos all in one spot, then just subscribe to my channel. So we're going to focus on chemical bonding in this chapter. So today we're going to talk about ionic bonding. We'll talk about covalent bonding in another section. So when the highest occupied energy level of an atom is filled with electrons, the atom is stable and not likely to react. So in a previous video we learned the first energy level can hold 2 electrons, then it's full. The second energy level can hold 8, then it's full, so forth and so on. So when they're full and don't have room for any more electrons, they are unreactive. The noble gases have stable electron configurations with 8 valence electrons, so they're full except for helium, which is in the first energy level, and it only has 2 valence electrons. Because remember, the first energy level can only hold 2. So all the noble gases have 8 valence electrons except for helium, which only has 2, and they're unreactive because they are full. So the chemical properties of an element depend on the number of valence electrons. An electron dot diagram is a model of an atom in which each dot represents a valence electron. So if you remember from a previous video, we said every element in group 1 has 1 valence electron. So if you look, each one has 1 dot. Everybody in group 2 has 2. Everybody in group 13, if you notice, they kind of mush the 2 sides of the periodic table together and they cut out the transition metals. Everybody in group 13 has 3, group 14 has 4, group 15 has 5, group 16 has 6, group 17 has 7, group 18 has 8, except helium only has 2. Okay, so you can tell how many valence electrons an element has based on where it is on the periodic table. So, not everybody is stable like a noble gas. Sometimes they may need more or need less electrons in order to be stable. So some elements achieve stable electron configurations through the transfer of electrons between atoms. An atom that has a net positive or negative charge is called an ion. So, for example, sodium, it just has a 1 electron in its outside energy level. So it would need 7 more to become stable. Whereas chlorine has 7, it just needs 1 more to become stable. So what happens is when they bump into each other or they collide with one another, sodium will give its extra electron to chlorine. And so now if you look, because we removed that last electron, sodium now has a full energy level and chlorine now has a full energy level. But because sodium lost a negative, it is now a positive ion. So it's sodium with a positive charge. And since chlorine gained a negative electron, it became negatively charged. And we'll talk about that's called chloride ion, but we'll talk about that later. So an ion with a negative charge is called an anion. Anions, like Cl-, are named by adding the suffix "ide". So for example, Cl is chlorine, Cl with a negative charge is chloride. An ion with a positive charge is called a cation. The name of the cation is the same as the element name. So Na is sodium, Na with a positive charge is still sodium. So that's why when sodium and chlorine bond, we call it sodium chloride. That's where the name comes from. Alright, so the way I like to remember that anions are negative and cations are positive is I like to say the T for the cation, the T looks like a plus sign, so it's positive. So the charges that an ion has are based on the number of valence electrons that an element has. And so if you remember, the valence electrons are based on what group they're in. So all the elements in the same group have the same charge. So here's our valence electron setup. So remember, the first group has 1, 2, group 13, 3, 4, 5, 6, 7, 8, except helium, which has 2. If you know how many valence electrons, it's the same for every element in a group. The charges work the same way. So where do these charges come from? So when we're talking about charges, we have to look at what's the easiest way for an element to be stable. Because elements are like us. They want to take the easy way out. They want to do the easiest possible thing. So, is it easier for lithium to gain 7 more electrons or lose 1? Because if you look, lithium has 2 in its first energy level, so that's full. But it only has 1 in the second energy level. The second energy level can hold 8. So it would either need to gain 7 more, or if it lost this one, then it would have this as its full energy level. So what's easier, to gain 7 or lose 1? Well, it would lose 1. That would be easier. So what charge would it have? Well, remember, you have to think of the fact that electrons are negative. So if something loses a negative, 1 negative, it becomes positive 1. So it would have a charge of positive 1. So everything else in the first column that has one valence electron will also form a charge of positive 1 because they will all lose that one extra electron. Let's move on to group 2. So we have beryllium. So beryllium has 2 valence electrons right now. So is it easier for it to gain 6 more to make 8 or to lose 2 electrons? Well, obviously it's easier just to lose the 2. So it's going to lose 2 negatives. So what charge would it have? Well, that would mean it would have a positive 2 charge. Because remember, the negatives and positives balance to make it neutral or a charge of 0. So if I remove 2 negatives, that means I now have 2 extra positives. That's where the positive 2 comes from. Don't think, like everybody wants to think, oh, well, if we subtract 2 negatives, it must be negative 2. It's not a subtracting or adding, it's a positive and a negative sign. So hopefully if you'll think of it that way, you won't get as confused. All right, so let's move over to group 13, where we have boron. So boron has 3 valence electrons. So is it easier for boron to gain 5 more or lose the 3? Well, it's easier for it to just lose the 3. So if it loses 3 negatives, that means now it has 3 extra positives, so it would have a positive 3 charge. And everything else in group 13 also has positive 3. So let's move over to group 14, which has carbon in it. So this is where it gets a little tricky. So is it easier for carbon to gain 4 more electrons or lose 4 electrons? Because if you look, it has 4 valence, so it could gain 4 or lose 4. So which is easier? Well, it could do either. It could lose or gain. So since it could lose or gain, its charge could be different. So let's say it loses 4 negatives, then it would have a charge of positive 4. But let's say on the other hand, it gained 4 negatives, then it would have a charge of negative 4. So everything in the group of carbon can be positive or negative 4. So you'll see me in class write plus or minus 4 for that column. So now we move on to group 15. And so we have nitrogen with 1, 2, 3, 4, 5 valence electrons. So is it easier for it to just gain 3 more or lose all 5? Well, at this point, it's easier for it to gain 3 because that's the less work it has to do. So then what charge would it have? Well, if it's gained 3 negatives, it would have a negative 3 charge. And so everything else in group 15 would have a negative 3 charge. So let's move over to group 16, which starts with oxygen. So is it easier for oxygen to gain 2 electrons or lose 6? So if you look, it has 6 valence. It needs to have 8. So it could gain 2 or lose all 6 and have a first full energy level. So it's easier for it to gain 2 instead of having to lose 6. So then what charge would it have? Well, if you gain 2 more negatives, you're going to have a negative 2 charge. And so does everything else in group 16. Moving on, don't worry, we're just going across the periodic table once. Moving on to fluorine in group 17. So fluorine has 7 valence electrons. So is it easier for it to gain 1 more or lose all 7? Well, obviously, hopefully you've gotten the pattern now. It's easier for it to gain 1. And so what charge would it have? Well, if it gains 1 extra negative, it would have a negative 1 charge. All right, so just bear with me. One more column. So we move over to group 18, to neon. Would neon want to gain or lose electrons? Well, if you look, neon has 8. So it's full. So does it want to gain or lose electrons? The answer is no, it doesn't want to. It's already full, it's already stable. So what charge would it have? Well, remember, atoms are neutral. They have 0 charge. It's when they start gaining and losing electrons that they become charged. Well, since it's not going to gain or lose, it would have a charge of 0 or neutral. All right, so hopefully that kind of helps you realize where the charges come from on the periodic table. So since elements in the same group have the same number of valence electrons, they all have the same charge. So this is a periodic table labeled with what we just went through on all those slides. So everything in group 1 has positive 1, then positive 2. Remember, we're going to skip the transition metals. Then we have positive 3. This right here, I know it's probably hard to read. It's plus/-4 because remember, that group could lose or gain 4. -3, -2, -1, and then of course noble gases are 0. Okay, so make sure you not only know how many valence electrons each element has, but you can tell the charges too. So a chemical bond is the force that holds atoms or ions together as a unit. An ionic bond is the force that holds cations and anions together. So remember, cations are positive, anions are negative. You have to have opposites to attract. So we can't bond 2 cations or 2 anions. Remember, opposites attract, like charges repel. So it bonds a cation and an anion. An ionic bond forms when electrons are transferred from one atom to another. So here's our sodium chloride example again. Sodium only has one valence electron, chlorine has 7, so sodium gives its extra electron to chlorine, and so then we have a positive sodium ion, and we have a negative chloride ion. And so now because they're positive and negative, they attract one another, and so they have formed an ionic bond at that point. When an ionic bond is formed, electrons are transferred until each atom has a full outer energy level. So sometimes an atom can lose more than one electron. So here we have calcium. Calcium has 2 extra electrons, but chlorine only needs 1 more. Remember, they want to be stable, so it's not going to accept if it's going to have more than 8. So what happens is when one chloride bumps into it, it takes 1 electron, and then a second chlorine would have to bump into it and take the other electron. And so then in this case, calcium, because it lost 2, would end up with a positive 2 charge, and each chlorine would now be a negative chloride ion. So in other words, when calcium bonds with chlorine, it needs 2 chlorines in order for it to be stable. So that's why things like H2O, that's where our subscripts come in, even though H2O is not through an ionic bond, it's through covalent, but we'll talk about that later. So compounds that contain ionic bonds are ionic compounds, which can be represented by chemical formulas. A chemical formula is a notation that shows what elements a compound contains and the ratio of the atoms or ions of these elements in the compound. So for example, you just saw calcium chloride, so it's CaCl2, whereas barium and oxygen form BaO. It's all about the charges, okay, and we'll talk about how to cross charges in a few minutes. But these are examples of chemical formulas, and so they show us the ratio of the elements involved in that compound. So a chemical formula for an ionic compound tells you the ratio of the ions in the compound. Solids whose particles are arranged in a lattice structure are called crystals. So you can see how we have this repeating pattern. These would be examples of crystal structure. So yes, salt is a crystal. Sugar is a crystal. Crystals are not just expensive gemstones you can buy at a jewelry store, although those are crystals also. But lots of things are crystals. Ice is a crystal. Ionic compounds tend to have high melting points, which high is considered above 300 degrees Celsius. Ionic compounds are poor conductors in the solid state, but they can conduct heat or electricity when they are melted. So the thing is, when they're in the solid state, remember in solids they vibrate in those fixed locations. So they can't move. Remember, for electricity to flow, we need charges that can move. They can't move if they're in fixed locations, but if you melt them into a liquid, then they can flow past one another and they can move and conduct electricity. Ionic compounds are brittle, so they shatter if you strike them with a hammer, so they're not malleable like metals are. The properties of ionic compounds can be explained by the strong attractions among the ions within that crystal lattice. So because those ions have those strong attractions and they're fixed in that crystal lattice, that's why they act the way they do, or have the properties that they have. So this is just an example of what I just showed you. So here's an ionic compound in its solid form, so the ions cannot move. They vibrate in their fixed location. But once you melt it, that's what molten means, or aqueous means dissolved in water. So if I dissolve salt in water, again, then the ions can move around, and that's when it can conduct electricity. So salt in its solid state will not conduct. But salt that's either melted or dissolved in water, once those ions are free to move around, that's when it will conduct electricity. So, section assessment. When is an atom least likely to react? When it has a full valence electrons. When it has full valence electrons, which for first energy level that would be 2, and for every other energy level that would be 8. Okay, I know we talk about 2, 8, 16, 32 like that. I meant 2, 8, 18, 32, but really it's 2, 8, 8, 8, 8, 8 when we're talking about valence electrons. So number 2, describe one way an element can achieve a stable electron configuration. Well, there's really 2 ways, so why don't we just go ahead and say both. It can gain or lose electrons. Remember, protons cannot change, but it can gain or lose electrons. Alright, number 3, what characteristics of ionic bonds can be used to explain the properties of ionic compounds? Remember, the properties of the ionic compounds are explained because of the strong attractions of the ions. Okay, so it's the strong attractions of the positive and negative ions for one another. Alright, number 4, What will the ratio of ions be in any compound formed from a group 1 metal and a group 17 nonmetal? Well, group 1 forms a positive 1 charge. And then if you look back, because I know you probably don't have it memorized yet, group 17 forms a negative 1 charge. That means group 1 needs to lose 1 electron. Group 17 needs to gain 1 electron. So it would form a 1-to-1 ratio. Okay, so the ratio would be 1-to-1 because they would both come together. It would be like the sodium and the chlorine. Sodium would give 1 electron to chlorine, and then they're both stable. So it's a 1-to-1 ratio. Why do ionic compounds include at least 1 metal? Well, if you remember when we talked about metals, nonmetals, and metalloids, your metals are on the left of the periodic table. The nonmetals are on the right. Well, if you think about how we just discussed charges, the positives are on the left and the negatives are on the right. And remember, you have to have opposites to attract. So metals tend to be positive and nonmetals tend to be negative. And since you need 1 of each, that's why 1 will be a metal, because metals tend to be positive. And then last one, number 6, based on their chemical formulas, which of these compounds is not likely to be an ionic compound? Well, ionic compounds, they're made of a metal and a nonmetal, because you need a positive and a negative. So if you look, K is in group 1, so it's going to have positive 1 charge. Br is in group 17, so it's going to have a negative 1 charge. So positive and negative would attract to form an ionic bond. SO2, S, if you look, is in group 16. It's going to have a negative 2 charge. O is also in group 16, so it's also going to have a negative 2 charge. So negative 2 and negative 2 would not attract through an ionic bond. So this would be one that would not form an ionic bond. And the next one is FeCl3. Well, Fe is in the transition metal area, which we kind of skipped over for charges. The transition metals, they can have multiple different charges, but the charges are always positive. So Fe is going to have a positive charge, and Cl is in group 17, it would be negative 1. So a positive and a negative would bond to form an ionic compound. So when you're looking for which ones would be ionic, you need to find something that has a positive and something that has a negative charge, and those would attract through an ionic bond. Whereas if you find 2 negatives or 2 positives, that would have to be a different type. So SO2 would be our example because they're both negative. Alright, so hopefully now you know a little bit more about how ions form and how we get charges on our ions and how to make ionic compounds.